Greetings. I would like to talk today about a massive shift I see taking place within the mathematics curriculum. My frame of reference is narrowly the state of California here in the United States. But this shift is occurring across my nation and I believe the world. We are in unprecedented times for humanity. Never before has our technology run so far ahead of our educational practice. Teaching and learning are being outstripped by the rapid pace of our technological moves forward. I'd like to posit, though, that there are hopeful signs and major shifts in education, especially within the quantitative sciences of statistics and mathematics. The first American arithmetic text is published in 1788 by Nicholas Pike, with a strong message of know these procedures and you know mathematics. Then in 1821, a counterpoint curriculum is introduced by Warren Colburn, an arithmetic on the plan of Pestalozzi, a book that heavily emphasized conceptual understanding, reasoning, and discovery. Thus began the American Math Wars. In 1892, there was an attempt to solidify the math curriculum by the Committee of 10. One of their major accomplishments was to create a coherent and complete treatment of the necessary mathematics for American secondary schools. It is they who created the geometry sandwich. A year in a course titled Algebra 1 is followed by a year in a course titled Geometry, followed by a year in a course titled Algebra 2, the first half of which recapitulates all of Algebra 1. This program of study has held sway in most of the country now for well past 100 years. Then in the middle of the 20th century, we find the US scared of the Red Menace, and when the Soviet Union launches Sputnik overhead, the country goes a bit mad. Instantly, we need more rocket scientists and engineers. Calculus must be taught in the high schools. At present, still, only 15% of American high school students complete calculus. Less than half of these do so with great success. Nevertheless, calculus has become the de facto goal and purpose for learning math for nearly every secondary student in the US. There are signs of it breaking apart, however, and this is where the good news begins. Early in the 21st century, there are many voices calling for a change in this calculus as goal. Two prominent ones that I'd like to bring up are Arthur Benjamin and Conrad Wolfram. Both go on TED Talks and deliver messages about Arthur Benjamin says, I want students to understand what it means to be 2 standard deviations away from the mean, and I really mean it. And since our math has shifted from analog to digital, it's time for our education to do so as well. Wolfram says maths is about 4 things: identifying problems, modeling or mathematizing those problems, calculating the mathematics, and reviewing the solutions and either refining your model or drawing your conclusions. Let computers do the work of computation and humans do the work that computers can't. Today, the Library of Congress is the largest library in the world, and it holds more information than any other single library. Yet we generate 50 Libraries of Congress's worth of data every second of every day. An equivalent of 50 Libraries of Congress worth of data is generated. Some of it is even meaningful, but how can one tell? We need to change the math that we teach children. The math we teach children is ill-equipped to deal with the mountain of data we generate. For instance, consider the COVID-19 situation. This is a picture of just one website's collection of one bit of the data that's available on transmission of COVID-19, the SARS virus, SARS-CoV-2. Just one. And these sites, some of them contain millions of data points. How will these students ever grasp the magnitude of the crisis and lend their minds and voices to its solution? How are they going to understand the cascading impacts of this pandemic unless we give them experience with this kind of data? How does knowing the topics within Algebra 2, like synthetic division or the remainder theorem, help them. Can we do better? I would say we must do better because the SARS virus is a dwarf compared to the climate crisis that's ongoing. And both of these will be solved by humans using data. A data science course is a solution. Yes, the data science course requires statistics, but it also requires the ability to tell stories with data using visualizations. It's technologically intensive. It requires a variety of data, both political, economic, health, mathematical. Data science has an application in all sorts of different fields. There is a change afoot. Courses in data science appropriate to the high school are in development and are being aimed at the third-year student level, that Algebra 2 level. Here in the state of California, we are making a path for this course to be accepted to meet math requirements and to formally write it into the framework of mathematics for the whole state. California is not alone in this move. Oregon, Washington, and other Western states. There are collaborators across our nation and around the world. At present, the University of California at Los Angeles, in conjunction with the Los Angeles Unified School District, have developed a data science curriculum that is available and at a cost that's on par with standard curricular options. Joe Bowler, Kathy Williams, and some of us at U-Cubed at Stanford are at work now to create a curriculum that will be available for free. It will use freely accessible and freely available public data sets, along with free tools from software tools and so on. This curriculum will be adaptable to local needs and data. It'll be capable of being driven by teachers and student interests and provide students with genuinely authentic opportunities to solve the problems we will face in the coming years. Whether it's CO2 or methane in the atmosphere, ocean acidification and warming, wildfires or hurricanes, waning fisheries, deforestation, all of these problems will be solved using a technology that's available now or in the coming days, and they will be solved with data-intensive methods. They will all be completed with real, non-fabricated data. This course will involve topics that include machine learning, linear algebra, and data visualizations. And it's due for release in fall of 21. In conclusion, we don't yet have the solutions for either SARS-CoV-2 or the looming climate crisis. But one thing is for certain, those solutions will require humans who can access, visualize, manipulate, and analyze, along with make sense and act on real data. It really is our only hope for survival. Thank you for your time, and I hope you all have a wonderful day.